the penultimate session slot at MIX. You're almost done. However, I'm not going to make this easy for you. So if you have peeked into my slides, they are really deceptive because they're really simple. This talk is going to have quite a little bit of complexity in it, in the demo part, as you would come to expect. My name is Clemens Fastas. I am a principal protocol surgeon on the Windows Azure AppFabric team. And there I'm responsible for, or co-responsible for the architecture of the service bus. So I'll be talking about the service that we have built. We have shipped the service. We are commercially available. You can use that right now. So I'm going to talk a little bit about scenarios that we're seeing customers use our service for. And as I'm talking about those scenarios, I'll talk what the service is all about, sort of embedded in those scenarios. Then for the people who haven't seen anything yet, I'm going to have a demo where I'm showing something that I've shown in similar fashion at the Professional Developers Conference when we announced commercial availability. And then I'm going to go into two segments, two other demo segments where I'm going to show some things that we have currently staged in the so-called labs environment, where we're trying out new features that are going to be in production in some form, probably not exactly that form, based on your feedback, where we have the ability to change things, where you can tell us how you want things to work. So we're going to show you that. And then at the very end of the talk, I have one thing that is out of a very special staged environment that I built for this demo, and this is showing code that we're currently building to enable other platforms, so there may be a little bit of a surprise there. But let's start with what is this and why? The first thing is make your own network, and of course the pictures here are all meaningful. This is a check-in counter in the UK of an airline, and that airline is working with us. They have a very interesting problem, like all airlines do. If you try to run an airline in an efficient way and try to expand your network, but you don't want to spend too much money doing so, and you want to keep the ticket prices down, you got to keep the costs down. If you whenever you go to an airport, you have to rent a desk. If you rent a desk at that airport, you also get, with the desk, you get a computer system. That computer system is different at all kinds of airports. There's major providers, but they're typically different, and they're pretty cryptic, and they're hard to learn. So all the ground personnel needs to be educated on this, and all those desks and the infrastructure and the transactions cost a lot of money. So what the airline said, hey, we can probably make things cheaper by creating our own network over the network that's available to us on site and just run our own check-in system. So instead of using those systems, we're going to build our own system. We're just going to go and federate all of our systems. All of a sudden, also your way of making check-ins becomes more effective because you're in control of the hardware. So they have Windows CE-based devices that they use, and they have a swiper for the card, they have a scanner for your baggage tags, they have all those things right on those devices. And what they now do is they run the check-in with those devices, and they go and federate them. How do they federate them? They use Service Bus for that. Because what Service Bus gives them is a network location independent overlay, a network overlay, where you can go and organize services, where you can plug in all those devices, you can send messages directly to them, irrespective of location. We have capabilities for online, offline, so there's a little message buffer, a queue-like structure that you can use for that purpose, where you can send a little bit of data, a message, to a particular destination, and then that destination is going to pick that up. We're going to see message buffers in action on your own device if you want to, a little later in this talk. So it's about making your own network. It's about creating an infrastructure that allows you to create a network interconnectivity irrespective of where devices are. And also irrespective of whether there are ports open or irrespective of whether you know the network. So That's the grand scenario one. There's another type of that scenario that we're seeing with another customer, and that customer is a fast food chain, and it's fast food franchise chain to be precise. They also want to have a common network for their whole franchise partners, so they have a common portal where they take orders for delivery service. All those sites, the restaurants are owned by individual owners, so they're providing the infrastructure. And now the orders come in through this national site, and from that national site, now they want to go and put the orders down to the restaurants. But instead of doing it all peer-to-peer and have 1,000 locations they need to go and manage, they need to go and create dynamic DNS for it, they need to know where they are, they need to do the configuration. What they do is instead they plug them all into Service Bus and they have a uniform network, a uniform surface to connect them through. So as I said, we're going to see what I mean with uniform surface later when we go into the demos. Next thing, control and watch your home. That's a big, big story. In the not too distant future, very many people will have a car that runs on electricity, even if not completely, then at least partially. This plug-in electric car that's coming. So what happens? You come home from work, you plug it in, it's 6 p.m., and your car starts charging. That would be really stupid. Because that's when power is in high demand, which means the power prices are going to be up. What that also means is now that electric cars are coming, these like super high consumers, the electricity companies are really thinking hard about what that means for them. So there's several efforts, it's a whole wave of efforts in the smart grid space. Smart grids are effectively ways for how the electricity company can help you manage your electricity demands better in your house. And there's multiple approaches to this. One of them is to get pricing information. What's the current spot price for electricity? To get that spread out, to get that information out to consumers, like hundreds of thousands of consumers. Where does that go to? People have boxes in their houses, embedded devices that sit in the house, and they're connected to other control devices, like your car charging system, or probably your heating system, or your lights. And so if you have a consumer like your car, or if you have a fully electric heating system, it makes sense to go and charge when the electricity price is lowest. So what the electricity companies can now do is go and regulate the demand through price. And you can participate in this by having one of those smart devices at home. And those smart devices not only give you that capability, but also command and control capability, tuning into home automation. One of my colleagues, our PM who's overseeing the billing and provisioning work, he's controlling his garage door, his outside lights, and a bunch of other things in his house using Service Bus. So what you can do with Service Bus is you can go and take you sit behind a NAT, right? Because that's what your home network gives you. You have a NAT, and now you have this embedded device which sits behind the NAT. That device can now create a listener, create an inbound channel through Service Bus to get command and control commands, so you can get to it from the outset using some application. Without any change to the firewall configuration, without the need to go and create any rules that allow inbound traffic. So your NAT, your home NAT, as it should be, can still remain totally stealthy. Because you don't want to have arbitrary traffic come in. But now think of this as a factory. Factory automation, servicing. You have a machine deployed on a factory floor. There's network these days. So how does a service technician from the manufacturer for that machine actually go and check on the health status on that machine if it's reporting, if there's reports that's wrong? How do they go in there and just fetch logs? how they connect to that machine. There's so many applications in command and control for home, industrial, and spaces where you have literally hundreds of thousands of or millions of devices which are sitting in that space that typically would not have a public IP address and probably shouldn't have one, but where you want to get to one endpoint. That's a big one for me and for a lot of you. So I'm on the road, and I'm in a different country, and I want to get access to my media. My media sits, the things that I bought, my digital media and my photos and things that I want to show sit in my house on my hard drive. I don't carry all of that around all the time because it's gigabytes and gigabytes and gigabytes of data. In another case, and that's something that I do personally, I always tell that story because it's true. I'm from Germany. I have a machine in my dad's house in Germany that is taping all kinds of TV shows because we like to go and watch German TV at home. So I'm pushing that then out to Kirkland, Washington, where I live. So I'm getting effectively 60 channels also live if I want to of German TV at my house. That's media integration. It's all good because I own all that media, but I want to get at it. So I need to have a way to go and reach into a media server that I have in my house without altering the surface area of my network, without exposing that server to the outside world. Nobody shall see this, just me. It's a little sluggish. And then lastly, for people who run and build systems that are server systems, which means that should be everybody in the room here, at least some parts on the server, it is really, really difficult to figure out what's going on in a system that's far away. Yes, there are logs, and you can write to logs, and you can go and download those logs, but that's not the kind of insight you need if you want to do a rapid cycle and development for a cloud platform, or if you just want to have real-time insight into what's happening in your system. So what we see here, several customers doing, is either building their own mechanisms, how they can reach into a cloud platform, basically bypassing creating a backdoor for themselves into their system. So if you're hosting something on Windows Azure, or if you're hosting something in EC2, all the customers, your clients, come in through the front door, right? So how do you create a backdoor for yourself so you can actually go and observe that traffic? How do you create a command and control infrastructure for individual machines or individual processes? Because in scale-out infrastructures like Windows Azure, the individual machine is not addressable for you. So if you want to build something that allows you individual addressability for command and control for individual machines, you can plug those machines into Service Bus and make them controllable that way. And of course, to get diagnostic data, like really alerts, things that need immediate attention. I can't reach my database, things like this. The way it's commonly done, writing it to a log file, that information sits there somewhere in a log file and waits a little bit. But you need to get this out. You need to alert someone right now. So that's what we see people using this for. So it goes from creating your own network, organizing your services over command and control for home and consumer scenarios and also for industrial scenarios, over access scenarios for media and other data, through diagnostics, monitoring scenarios. So there's a lot of very broad wingspan of things that we see customers do with the Windows Azure platform AppFabric, especially with the Service Bus. So here's what we do right now. I'm going to show you some interconnection examples and some examples for things you can do with the system. So here's my notebook. Yes, and this is a very, very old website. So this is an example. This is an example that we built, or that the colleagues at DPE built in 2006, I believe. So it's got a 2006 feel to it. There's a little bit of Ajax in there, but it's not that much. It's certainly no Serverlite. But it's a perfect application to show what I'm going to show and what I want to show now, because this application was not built with a cloud in mind. So what we have here is dinnernow.net. The business model of that company is very simple. They provide delivery service for restaurants that don't have delivery service. So they keep all those menus, and you can go in there and you can go and order something. So what I'm going to go do is I'm going to sign in. And it takes a little while, and it's kind of surprising. Something happened. The interesting thing is I know exactly what had just happened, because here's my little CloudTrace recorder. So this is the first thing I'm going to show you. This is just a trace, right? So it's not all that interesting all by itself. But the interesting thing is what just happened. This is an application that runs inside of Windows Azure. What just happened is that a connection to a particular database timed out. I know exactly why. But I just got that dump of that exact sec trace into my window that sits here on this machine. So what I'm doing is I'm observing in real time what's happening up in my cloud system. So I have this hooked up. See, and now something else has happened. I'm observing exactly the state and all the traces that come out of this web role. So I have on service bus a so-called event point. To the event point, there's a trace listener that's plugged into system diagnostics. And what that does is it listens, takes the events, and then puts them onto this event point. I then go and have my CloudTrace recorder here. That's the app that runs. And that subscribes on that event point. And I can have any number of subscribers on that event point, and everybody is now getting those trace results in real time. You can feed them into, obviously, a simple window like this, or you can feed them into an actual monitoring system, what you would usually do. But this is a way to gain real insight into the system. So how does that work? That part is really easy. I'm going to show you those things step by step. So here we have the web config of the website. All the way at the bottom, I have this listener, the CloudTrace listener. And that's just a modified version of a sample that we have in the AppFabric SDK, which effectively just hooks this up to an event point. And we can even go and take a look at it if you want to. So that sits in common, and it sits here. Where is it? We're going to look at the client side of that. Passwords. See, this is videotaped, so now I got to destroy the account. So what this does on the client side is it's creating from our SDK, it's creating this CloudTrace receiver. And what this receiver does is it subscribes on service bus to CVSB demo service bus at windows.net. That's the place where I have that event/traces. That's where that sits. And if we go and actually observe the structure of that namespace, which we can, then we're going to see that listener sit there, or that endpoint sit there. I surely hope. Okay, so here's what I mean with common infrastructure. Let's make this a little bigger. So what you're looking at is an Atom feed of services. So what I'm doing here is I have a listener that sits inside of this machine, or I have listeners that sit inside of Windows Azure, or listeners that sit somewhere else. And all of them can create listeners. They can create listeners that receive messages. And I can plug them into this namespace. So all of a sudden, I have a very uniform surface for my services. I also have a very uniform way of configuring security. because it's all overlaid with the access control service, so that nobody who doesn't have the right, governed by the access control service, to access that service can actually get in. So we have orders, we have port bridge, we have events, so we have those services, and even though they sit in all kinds of different places, now I have a uniform place. They all have a stable name in the world, irrespective of network location. And this is how I name this is how I reach them, and this is how I can talk to them. So this was the very simple tracing demo, right? So let's go and see what happens when I hit this again. Now, magically, it worked. Something else happened just now. What was that timeout all about? Now, the timeout was about this here. You see incoming connection for port 1433. And for those of you fluent in all things TCP, this is SQL Server TDS, the SQL Server TDS port. So this application here is interesting because it wasn't built for the cloud. And if we look at the databases, there's one that's about catalogs and about restaurants and about menus. And the other one is about personal data. It's the profile database. This holds your credit card information, it holds your profile information, it holds all those things. Customers come to us when it comes to Windows Azure and they say, I am a tiny little bit nervous about putting the private data of my customers into the cloud. And we can talk through whole day and night about how we're safe and how we're secure and how it's all beautiful. The customer feels uneasy about it, and that's okay. In reality, today we have in many systems, we have so tightly integrated our data stores, and especially customer data, that they're likely sitting in some CRM system, and that's the master for everything that has to do with customer. And it's likely also where their profiles sit. Where's that CRM system located? In the data center, and likely in yours. Sometimes you sit on a SaaS solution, but it doesn't sit in the Windows Azure cloud. So how do you reach in there? There's multiple ways of doing so. You can go and take your database fronted with a service and expose it to a service bus. Or you could go and reach straight into it, and that's what we're doing here. So what I'm doing here is I create this website has its profile database sitting on this machine. Let me say that again. The website is hosted inside of Windows Azure, deployed in the San Antonio data center, and the profile data, the customers, credit cards, and all that information comes from this box. This is why I was timing out, because it needs to warm up a little bit. And this is why we're getting those connections in. How do I prove that that's true? Well, let's go and so I'm going to go and refresh this. And it's all working nicely. Let's kill the database. Database is gone. Website unhappy. So this is about integrating the cloud with on-premise. This is an example of tunneling. We also have examples, of course, of service remoting, where you have a service and you're fronting that with it. When you consider moving stuff to the cloud, you will always find cases where it's impossible to move everything to the cloud, where you have on-premise assets that you want to reach into, where you just can't do cloud computing all the way. And I'm going to show you how I did this particular trick and then I'm going to move on. So you will always find cases where it's just impossible for you to do a wholesale cloud story. There's several indicators for this. As soon as you have a touch with the physical world, you need something like Service Bus. You have a POS terminal that sits somewhere in a mall, and you need to go and send something to it. You have someone who's running around with mobile devices, aren't we all? And that shall be integrated in your application, and you need to push data to it. you have any kind of asset in your local data center or in your department server, and you want to go and access that from a website, you need to have something like this. So how is that done? Also relatively simple once you have the code, and that all that code is available from my blog. What I'm doing here is I'm wiring up this, have a connection string here. That's the wrong one. I have a connection string here. And that connection string is in the web config, not in the app config. It's that easy. So I just had it. Where is it? There it is. So here's a connection string. That connection string points to another instance on Windows Azure, cvsb demo1 svc.cloudapp.net. So what I'm doing is I'm hosting a TCP listener inside of Windows Azure in a worker role. And now what that TCP listener does, so that's what the web role talks to. And what that thing does is, here's the worker role. It's relatively simple. This employs a TCP client connection forwarder. That thing is in a library that I put on my blog, and that's also in this whole download. And what this thing does is it listens on TCP, and then takes that TCP stream and remotes it through Service Bus, and it pops out on the target machine, and from there it makes a connection down to SQL Server. So you're basically just tunneling the whole socket through. Because of the efficiency of the protocol that we're using the .NET NetTCP protocol that's built into WCF. We have commonly an overhead of about 48 bytes per message. So all the SOAP glory, the SOAP envelope, and all the namespace and all this shrink down to 48 bytes. So that's the overhead that we have. And then what we're getting in addition is we're using nagling on this connection. And so we're getting an overhead just about a 1%, or even sometimes better than 1% if you're pumping a lot of data. So that's this client connection forwarder, and the code is all there on my blog, and the address is at the back of the deck, where you can go and download this whole application, this whole thing, and play with it. So that was this. So we can go do service remoting, we can do eventing, we can do that for, we can hook it up to workflow. That's something that I haven't seen, but if you go and want to take a look at that code, that will certainly show you that. So we've seen monitoring, we've seen interconnection that's a path where the orders go. We certainly have seen notifications, how you can notify other people of things that are going on. But we're going to do a little bit more notification. So this is where we are. We have a structured service. You can hook listeners into it. You can create little disconnected message buffers in it. You can explore all those things, watching the talks that were given at PDC in more detail, or our SDK. So this is what's shipping. What's now is future. This is the closed future. These are things that are already on the roadmap and that we're building out. To try this, look at that. I thought they would edit that deck. I told them to edit that deck, so I'm going to edit that deck right here. So if you have a mobile device of some sort, even of the other sort, or you have a notebook, you can hit this URI right now. What you're getting is a little game. What you also will be doing is you'll be using the newest feature that we have. So let's go and take a look at that. So it's mixbingo.cloudapp.net. It's very easy. Mixbingo.cloudapp.net, because I'm just going to take it away from you for the moment. Okay, here we go. This can go. Let's close this. Let's go here. mixbingo.cloudapp.net. This should be, so this is the UI. This should be working on the iPhone. This should be working on the Android. This should be working on Windows Mobile with the Opera browser. So this is working on a bunch of platforms. It's working in Chrome and in Firefox and in all common browsers, and it's very simple. And Bingo is very interactive. It's not actually the only interaction that's in that game I took away from you. So what I'm doing here is I'm getting a card. Okay, and now we're playing, and it's catching up on the numbers. Everybody's kind of catching up on the numbers. And at some point, it'll stop going up with the numbers, and it'll be synchronous between most of us, depending on how far we are in the game. This is actually quite good. So let's go and put that on the side. Let me go and get a WebKit browser. So let's go and take Chrome. So you're going to see now Chrome kind of catching up. Oh, it's racing ahead. We may have joined in the middle of a game. So this Bingo engine sits in the background, is deployed in the data center and plays Bingo. And you can join in, you can get a card, and you can just play. So you can observe. You can actually, I could stop the game now, or you could stop the game now by yelling Bingo. As soon as you have, you can cheat in the implementation. Because I didn't know whether I would get Bingo. The only interaction is that clicking the bar up there, once you have one of those red things, that's going to go and stop the game. So now the game is over. We're done. We're done. I know. Someone else has won. Good. So that's the game. If it kind of hangs, then you can go and reload it. The interesting piece here is, so the next game has been announced and all those things. So it's all good. So the game is kind of semi-interesting because I'm not a UI guy, very apparently, and my game was not to build a bingo game, but actually to show you how the technology works. So let's go and take a look here into what's happening with this application. So in this app, and I just closed what I want to have open, the board is this Bingo ASPX page, and I'm gonna make this available, this app, so you can actually take a look at it on my blog within the next several days. Come on, there it is. So that's the Bingo's ASPX page. That's the card that you see. So there's a default ASPX, that's the general layout, and then this is an iframe. The iframe is pulled through Service Bus. So you loop, it takes once a loop through Service Bus, so now we have same origin policy with Service Bus itself, so it can actually go and now talk to Service Bus. So this page gets served up, and this is just a normal run-of-the-mill HTML page with, and this is kind of where it ends, and now comes a lot of jQuery. But it's actually not that hard. So let's go and take a quick look at this. So the first thing I do is I start the game, which means I go and do a post. I do a post against the player's card service. So that's a normal REST service that's built with WCF, that's served up through Service Bus as a REST service. So we do SOAP, we do REST, we do arbitrary content types. So here, I'm exposing through Service Bus, clemensv.servicebus.appfabriclabs.com, because that's a labs feature. I'm talking to this and I'm posting and I say, hey, I want to have a card. So it comes back with the card. at start game success. So it gets the card. The card is actually delivered back in JSON. So we do plain text, or we do any content you like, and we also do JSON through the service bus that we can serve up. And now it goes and gets the data out. It fills the grid, and then starts listening. And this is when you see the toast popping up. So filling is not so interesting because that's all about jQuery. So what is listen all about? Listen goes against a URI that we get back with that card, so that we get back, and that's a service bus message buffer. The service bus message buffer allows you to go, and it's a little buffer that holds a bunch of messages, and you can go and send messages in there for reception by some client. So I created a message buffer on the server side. I configured it to allow anonymous reads, but it's configured to require authentication on write, so nobody else can use it. So I'm just assigning that to a user, and I'm saying post on the head of the message buffer collection, which means please do a lock. Give me the first message, peek it, and then put a lock on it. And please observe the following parameters. Timeout equals 60 means if there's no message present, don't come back to me. Come back to me when you have nothing, when you have found nothing, only after 60 seconds. So we will park that request, which means that there's no additional traffic happening. You issue a request, you hang there for 60 seconds, and then after 60 seconds, you do a quick round trip that acts as a keep alive effectively for the socket, and you park the request again. So the impact on your machine there is very minimal, and actually it's also good for power consumption. So lock duration means if I get a message, that message now remains locked for 30 seconds, and I want to do something with it, because in HTTP scenarios, it's very often that the socket tears or something happens, and so you may lose the message in transit. Now, this game is actually dependent on having all the messages come in, so we can't afford to lose a message in transit, and therefore I'm locking this. So this is why I'm doing the post here, getting the message out, and whenever I have processed a message successfully, here I am. Once I'm done with the work, I will go and then delete the message and continue working. And deleting the message effectively means that I'm getting a header back, I'm getting a lock header back, and I go and I can do this here. I'm actually doing a delete here. Here you can see something else that we do here on our little message buffer. And that is, so I'm deleting the message now, which is a delete. A bunch of browsers can't do a delete from AJAX. So what we've done is we have an XHP method override in the system that you can go and where you can specify the actual HTTP verb you want to go and use, even though your client stack may only be able to do post and get. So it will not freely allow you to go and specify something else. So that's a cycle. This is how you do this from a normal web page. So we're creating a back channel into your system that you can very easily set up from the server, where the server can feed data to. The new thing, so this is what we've done this already in the system. So that's this is new, but the rest of the things we have already done. The new thing here is to be found on the server side of the world in how I go and configure this. So as I'm setting up this card. So here's get the game board, and here's where I'm creating my card. I'm saying make an event source. So here's where my game card is created. I'm creating the event source. I'm actually generating a card ID. So all the cards that I'm dishing out are digitally signed. So if you yell bingo and you give the card back to me, I can tell whether you cheat in the protocol. So that may be an interesting thing. Once I give you the code, that may be interesting to just look at. It's very simple. So I go and make the event source. And making the event source is what we effectively want to look at. And that's down here. And that's this code. So we're going to make this a little bit bigger, and then let's go look at this. So I'm going to go and create a service bus address. So I'm creating an HTTPS address with the service bus namespace that I have here, and then I'm getting a token for it. So I'm creating the message buffer location. This is the place where the message buffer lands, and the message buffer is created with, as you see up there, I'm just creating a new GUID. So in the namespace, I just create a GUID and just use that as my name for that message buffer. And now I'm creating that message buffer URI, and now I'm getting a token for it, which means I need to have the right to create that in the namespace. So now I'm trying to get from access control, from the access control service, I'm getting a token. I'm creating this, it's a protocol we call WRAP. So the rest, that protocol, an authorization protocol, has been developed together with Google and Yahoo as a profile of OAuth. So that's what we're using here. And then there's a little helper that allows us to create this message buffer. So that's step one. The new thing is that we can, gotta go and make this a little smaller again. Scroll this here and show you. That we can go and subscribe. Now I'm going to go and drill into that code whenever Visual Studio decides to let me. All right. So I'm going to take a look at this because that's the new part. So far you could create message buffers, but you could not subscribe into them. What we've now added in Labs is the ability to go walk up to the message buffer and say, hey, why don't you start listening on a different name? And that different name may be a unicast or a multicast name. So all of a sudden, you now have the ability to create very, very many message buffers and hook them up to the same event point. So we can now drop one message in. That message gets flooded to all the message buffers, but everybody keeps their little queue and has individual state. And now this is getting really interesting for scenarios like the one that we just built for the bingo game, because otherwise you just can't do it. The bingo game goes on, and everybody is getting synchronized events pushed out to their phones or pushed out to their computers, all at the same time, because I'm dropping one message in, it gets flooded across all the message buffers, and as you're polling, you're getting the respective message. So the subscription is very simple. We go to the subscriptions node. So under the message buffer is a subscriptions name. It's a subscriptions collection. It's all RESTful. There's actually an Atom feed for the subscriptions collection, so you can actually see what subscriptions you have. And now I'm posting a very simple property bag where I'm saying, is this multicast? What's the target URI that I want to go and subscribe to? And what's the token that I need to go and subscribe to? That's all. So I need to have 3 parameters. I need to have a token acquired, so I have the right to listen to that address. I need to have the target address, service bus namespace / whatever name it is, and then you indicate with true or false whether that's a multicast subscription or not. And once you've done that, you now have a listener. Now your message buffer has a secondary sort of entrance into where you can send messages to it, including the ability to just create multicast groups by specifying the same URI for a bunch of message buffers. And that's exactly what I'm doing in this sample. So that's the new thing. It's a tiny protocol addition, but it's extremely powerful and opens up a ton of new scenarios. So that's feature 1. The other feature is in the same file a little bit further down. Because this is the Silverlight show, even though I'm lacking skill in that area, have indeed written a Silverlight application. Actually, the first version of the Silverlight application, the code was so embarrassing that I threw it away and spent all day yesterday re-implementing it. MIX was so inspiring that I missed half of it. So here, same layout, almost looks the same. I didn't make it quite as pretty. But I go in and say play, and there are my numbers. And I have no luck because it doesn't show any numbers, but you believe me, it's working. I just have a bad grid, or the game is currently paused, as it happens. Well, usually, so this is now served up from an arbitrary web page. It's actually served up from my local machine. This comes from localhost, but it still talks to the actual fabric. So it talks to service bus. It talks to the service that sits deployed on service bus. Now, as you all know, there's a problem. Cross-domain calls, same origin policy, and all those things that just wouldn't work unless you do something. So what we added in service bus is we created 2 buckets for you. One bucket is fittingly called client access policy.xml. The other one is fittingly called cross-domain.xml. These are just 2 XML buckets. We are not prescriptive about the format. We're not creating that format for you. We're validating that it is, in fact, a client access policy, but we don't do anything magic in there. So we take that little bit of state and we replicate it across the system. And now you can go and you can take your namespace where you have plugged all those services. And you can now say, okay, so in my namespace, I have the following organization of services. Here's where all the services land, from all the devices here I have. This is where the CRM system lands. So you have a layout, you have a design for your namespace where everything plugs. And now you can write a custom policy for things you want and things you don't want to go serverless enable. And you just put that into that file. Here, I have this in that helper. Put that into that file and upload it with a simple put into that location, and it's simple, but you also need, of course, need to provide the token, the authorization token, for service bus, so you have management right for the namespace. And with that, you enable Silverlight right away. So that's the 2 new things. It's very small additions, but really powerful enablers for a lot of scenarios when you do web applications. In terms of, let's be clear, in terms of scale and pricing, when you look at the packages you can buy, if you go into the business page, if you go to azure.com, appfabric.azure.com, or go on our portal, you will find that this is more suitable at this point to enterprise applications than to broad consumer applications. Because typically when you write a broad consumer application for tens or hundreds of thousands of people, you typically have the muscle to write some of that infrastructure yourself. But for tactical things, for smaller apps, for enterprise apps, you typically don't. And that's where we have a really good value proposition. So that was that. So new features. Serverless client access policy.xml, cross-domain access to service bus, cross-domain access to access control, something that was sorely missing. If you want to build a serverless application that's leveraging access control, federating with other identity providers, you were not able to do this before, now you can do that. And we're also supporting the cross-domain XML protocol as specified by Adobe for Flash. And then you've seen the message buffers with multicast support. You've seen them live. If you go to mixbingo.cloudup.net, I'm going to leave that on for a little while, not forever. It's labs. But you can go and toy around a little bit with the bingo game. I'm going to go and make that available so you can look at it. Futures. So this was labs. This was futures. Now we go and do futures. And this may be a little bit surprising. And the reason why we're talking about this is not that we're done, because we're far from being done, and not because the demo is fantastic, because it's actually not working correctly, because something fell over in the data center just before I got here. And it's my private deployment. I would have to fix it, and I couldn't. But I'm going to take you as far as I can. But it also is an indicator that we're not really only a .NET play. And that's not our understanding of what we are. So right now, if you have .cf, if you're building .cf services, we're plug and play. We're really easy. You just change the binding, and you can expose your services out to service bus. If you are building simple HTTP services, yes, you can use the message buffer. You have this long polling mechanism, which works really well. Very simple model. But sometimes you just want to have a permanent connection. Sometimes your events must be timely. Sometimes you have bursts of events that you need to deliver timely. This is where you need to have a binary TCP connection, where the polling thing is just not doing it. How are we going to enable this? How should we do this? So we're thinking really hard on how we can do this. And what are the right protocols? So what are we using right now? Right now, you create a listener. What happens is under the covers, we're creating a TCP socket, and that TCP socket is formatted with the NetTCP protocol that's part of .cf. There's two fundamental protocols that are used in that. There's .NET framing. What that does is it formats the socket and says, where's the boundaries between messages. It also indicates, in-stream TCP upgrade. It also carries an authorization token. So it's doing the basic negotiation. And then we use the net message formatting, which is an XML compression mechanism, binary XML mechanism, that sits on top of that. There are not very many implementations of those two specs, even though they are published and in the open specification promise. There are other protocols with similar momentum that have the exact same with great momentum, which have similar characteristics. One of them is XMPP, and so we're playing with that. And so let me go and show you this. So we're in the debug state. Oops, sorry. My stupid mistake. Score me down. So we're in the debug state here. There's data going across the wire, and this is inside of Eclipse, and this is running inside of Android. So here's a native Android application, the same bingo game, hooked up to Service Bus, to a special version of Service Bus that you can't access. It's got a handwire lab build on it. There has been literally no testing done except for me. It sits in the data center, sort of in its own isolated place, and it's got a full XMPP head on it. So what we're looking to do. And I'm not standing here saying Microsoft is announcing XMPP support for Service Bus, because that's not what I'm doing. We're currently exploring this framing protocol. And by the way, this application would have been impossible to actually get finished and even get in this state without the help from someone in the Android development community who has been helping me debugging the server against his library. So what we're doing here is we're exploring what other protocols to support, and XMPP is currently a very hot candidate. So this is why we're doing this. So let me show you very quickly what this is all about. The application itself is not so interesting. I will do probably a video recording of going into the detail and showing how that app really works. Let's go and take a look at it, at this application a little bit. So here's my Android app. Oops, no, that's the layout part. Oops. So let's go and look at the source. And now all the Android experts and Java experts out there are going to be laughing when they look at the video, likely. So nothing interesting happens here yet. So here's start the game. When I'm starting the game, I'm doing exactly what the other versions of the game do. So I go to the URI, I go and get the card, the player's card, I'm getting the direct card, so that has a different URI in it. And then I'm going to go and open the connection. I'm going to get the reader, and then I'm going to go and deserialize the card, and then go and start. And so starting is the interesting part. Let's go and get there before you all get dizzy. Deserialize card and start. I know it's in this class. I'm sure it didn't go anywhere. There it is. Look at that, yes. See, it's just so much, it's so little code. This is the Microsoft API in this whole game, right? It's called one-way listener because that's what it is here in this case. It's a one-way listener. There's a URI. There's a simple token provider. The simple token provider is gets an owner and then, or gets the name of the issuer. And then if I go further here, I have a resource from which I'm pulling the key. I'm saying, yes, this is a multicast endpoint. And then I say open, and then I say begin receive. And then whenever I receive a message, I dispatch that to that callback function or to the callback object to be correct because this is Java, and then call dispatch message. What dispatch message does is it takes the message that comes into the XMPP stream. So we set up the parser here. And now I parse into the document, and I see this is an XMPP message stanza containing a SOAP envelope, containing SOAP headers, containing a SOAP body, and here are my messages that I have. They're called start, they're called stop, and they're called wait. These are the messages that cause the game to run, and whenever I get one of those messages, I'm popping a toast up that shows what the current state is. So just as much as you've seen the effects coming in, that's the same thing. So that's a native, this is not using the HTTP mechanism, this is using a native XMPP listener against Service Bus. And we're testing this against libraries in Perl, we're testing this against various libraries in Java. We haven't done the work yet on Objective-C, that's mostly because my boss hasn't given me a Mac yet. And against all platforms to see what the right protocol is. So there are other candidates, obviously. There is SIP. SIP has similar characteristics, it gives us the framing. There's other candidate protocols, but we're currently looking at XMPP mostly because it's the hottest protocol that we see out there, and this is why we're doing the first investment in this area to figure out what the right thing is. The reason why we're doing this, and this is why this is looping back to the beginning, is because we get a lot of demand for non.NET platforms. And the reason for that is very simple. When we go back to the picture of the house and all those embedded devices, those may run Windows, CE, but even on the CE platform, there's no full .NET framework. WCF that we rely on has the listener part doesn't exist in Serverlite, it doesn't exist, the whole server portion doesn't exist in CE, doesn't exist in all the operating systems that are meant to be client operating systems. Now, we're turning clients into servers. So we're just sitting there, even though the WCF team is right next door, and they're saying, like, it's kind of difficult because there's a lot of stuff to import. So even for our own needs, we're looking to have a protocol that we can implement very, very simply using some off-the-shelf libraries. And of course, there is an XMPP stack that I wrote from scratch for this, that we can easily use on all those platforms and is optimized for at least the .NET platforms for Silverlight and for Windows CE. But on very many embedded platforms, there are XMPP libraries for C, there are XMPP libraries for C, for Objective-C, for C++, for Java, for whatever you name it. And it's likely that on other platforms, specifically embedded platforms, mobile platforms, we're going to have that support, and so that's why we're looking at it. So much as a glimpse into the future that there is motion, we're doing things, it's not that we're sitting down, I think we're just getting started, we have the system running. The system is deployed, and now we're going to go and look how we can extend the reach and really go into scenarios of consumer scale, of consumer device scale, like the ones that I outlined. And what we're interested in is feedback on whether that's the right way, whether it's the right protocol choices, whether we're thinking about the right platforms, what kind of scenarios you think you would enable. And if you look at the pricing, you say, that's too expensive for me, come to us and say, why? And you say, I have 100,000 connections, or I have 1 million connections, and here's what I want to do. Come talk to us about that. So it's not only about the pricing, but it's also, is the model, are the bundles, is that right? Because this is all still early, cloud computing is early, and we're really, really looking for feedback and ideas. So that's my blog, blogs.msdn.com/ClemensV. You find there the download for the big demo at the front. I'm going to bundle up the bingo demo probably until next week. That's going to wait a little bit just because I need to make some things better. And if you want to follow me on Twitter, you can do that at ClemensV. That also happens to be my email handle at Microsoft and at Gmail, I think, too. So far, don't forget to fill out the evals because they pay me based on the returns that you do. And otherwise, we have 43 seconds left for questions. Nobody's jumping up? Well, then thank you and enjoy the rest of the day.